So we already looked at some special forms that have specific factorizations that work in order to factor the polynomial. We're going to look at another couple of specific forms. Particularly, we're going to look at trinomials of this form, ax squared plus bx plus c. So where a, b, and c are constants, and then we have a variable squared, and then a variable to a first power, and then just a constant on the end. So trinomials of this form. And we can split these up into two cases. The first case we look at is where this a is actually a 1. So when there's a leading coefficient of 1 on the polynomial. An example would be something like this, x squared minus 2x minus 3. In this case, the factorization is not too bad whenever a equals 1. When a is not equal to 1, we have to do a couple of extra steps. So if you look in your notes, you'll see the whole outline of this. But the idea is that you want to look at, in this case, a equals 1, b equals negative 2, and c equals negative 3. We want to find two numbers that when we multiply them, we get c. So when we multiply, we get negative 3. But those same two numbers, when we add them, we get b. So when we add them, we'll get negative 2. So in this case, the two numbers that work are negative 3 and 1, because when you multiply negative 3 times 1, you'll get negative 3. But when you add negative 3 plus 1, you'll get negative 2. So these are the two that I want to use. So that means that I can actually just split this up into x plus the first term, so x plus negative 3, or I can just think of x minus 3. And then x plus the second number, so x plus 1. So this actually factors into x minus 3, x plus 1. And if I check it, it should work out. X times x is x squared. X times 1 is 1x. Negative 3 times x is minus 3x. Minus 3 times 1 is minus 3. And then x minus 3x is negative 2x. So sure enough, that works. And I get back to the expression that I started with. So let's try another one. So x squared minus 9x plus 20. In this case, again, I'm looking for two numbers that when you multiply them, they equal 20. But then when you add those same two numbers, equal negative 9. The 20 comes from here, and the negative 9 comes from here, from the b. Now, if you ever have trouble doing this, sometimes you can get numbers that, I don't know, maybe they're not totally obvious right when you look at them. So there's a pretty good trick to figure this out. You can always just take that number, 20, and then just write out all the factors of 20. So 20 can be 1 times 20, it can be 2 times 10, 4 times 5, right? Or it can be the negative versions of all of those. So it could be negative 1 times negative 20, because that's still positive 20. Negative 2 times negative 10, and then negative 4 times negative 5. So make sure you remember to put the negatives in there as well. Because in this case, then I just need to look through all of these sets and see which of these add together to get me a negative 9. In this case, the negative 4 and the negative 5 will add together to get me a negative 9. So those are the two numbers that I would like to use. So this will actually factor then into x plus negative 4, or x minus 4, and then x plus negative 5, or you just write it as x minus 5. And that should be the factorization of x squared minus 9x plus 20. So we'll look at one more. X squared plus 8x plus 16. Again, what two numbers multiply to get 16 and add to get 8? Well, let's just go over here and write out all the factors of 16. This could be 1 times 16, 2 times 8, or 4 times 4, and that's all, right? Because then we get to 8 times 2, which is the same thing as 2 times 8. Or we could have a negative version, negative 1 times negative 16, negative 2 times negative 8, negative 4 times negative 4. And so I just need to look through these and find which of these add together to be positive 8. And it turns out that it's these two, 4 and 4. So that means that my factorization will come out to be x plus 4, x plus 4. This is actually a special kind of trinomial because this is really just x plus 4 squared. So we say this is actually a perfect square trinomial. Just like something like 64 is a perfect square, right? Because it can be written as 8 squared. This is a perfect square trinomial because it can be written as one expression squared. So let's look at the case where the first leading coefficient is not a 1. We have a couple extra steps in this regard. So 2x squared minus 9x plus 10. The first step we always want to do here, as you can see in the notes as well, it has this outline. Take a times c, so in this case a is equal to 2, b is equal to negative 9, and c is equal to 10. The first thing I want to do is take a times c, so in this case this will be 2 times 10, which is equal to 20. And now I want to find two numbers that when they multiply, they equal to 20, a times c, but when I add them, I want them to equal to my original b, so I want them to equal to a negative 9. So in this case, again, I can go through and figure this out by doing all of the factors of 20. And the one that I want is the negative 4, negative 5. But in this case, I can't factor quite yet. I'm just going to rewrite my original expression. Instead of negative 9x, I'm going to rewrite it as negative 4x minus 5x. Right, because that's the same thing. Negative 4x minus 5x is equal to negative 9x. And then I'll have the plus 10. So I'm just rewriting the expression with some different terms. And now the idea is that I can group this and factor it by grouping. So I can group the first two terms together and the second two terms together, and hopefully I'll be able to group this and get something out. So here I can factor out a 2x from the first group, and I'll get an x minus 2. Here I want to factor out a negative 5 because I want the x to be positive and the 2 here to be negative. So I'll pull out a negative 5 instead of a positive 5. So this would be x minus 2. Now I can factor an x minus 2 to the front, and I'm left over with 2x minus 5. So this should be the factorization of 2x squared minus 9x plus 10. So you can see this is a couple extra steps, but still not anything too hard. You just have to remember the process and be able to work all the way through the process. So let's try one more. 6x squared minus 5x plus 6. Oh, sorry, minus 6 is what we have in the notes. So again, a is 6, b is negative 5, and c is negative 6. First thing we do is take a times c. So 6 times negative 6, so this is negative 36. And I want to find two numbers that when they multiply, they equal to this guy, negative 36, and when they add, they equal to my original b, so negative 5. In this case, the two numbers, well, again, if we're having trouble, go over here. Okay, to get negative 36, I can do negative 1 times 36, negative 2 times 18, negative 3 times 12, negative 4 times 9, or negative 6 times 6. And that's all, right? And then I can go over here and do the opposite of that. So 1 times negative 36, 2 times negative 18, 3 times negative 12, 4 times negative 9, and then 6 times negative 6. So the opposites of all of those. And it turns out the two that add to get negative 5 are 4 and negative 9. So those are the two I want to use. So I'll rewrite my original expression. Instead of a negative 5, I'm going to rewrite this as plus 4x minus 9x, and then minus 6. And again, I'm going to try to group this. So I'll group these two together, these two together. Here I can pull out a 2x, So I'll pull out a 2x and I'll be left with a 3x here, and then a plus 2 here. Here I want to pull out a negative 3x, because I want this to be positive and this to be positive. So if I point out the negative, it'll change the sign. So this will leave me with a positive 3x and plus 2. Again, these two are exactly the same, so I can factor them out to the front. And then end up with 3x plus 2 times, oh, I'm sorry, I made a mistake. This should only be a 3, not a 3x. Okay, a minus 3. So this will leave me, when I pull out the 3x plus 2, I'll be left with a 2x minus 3. And I'll get that for my answer.